Good afternoon, everyone, and welcome to Demo Day of Batch 627 here at the Wagon Amsterdam. Today, we're here for a very special occasion, which is the graduation of our 12 data science students who just completed a 9-week, very intensive data science bootcamp here at the Wagon. First of all, congratulations for this massive achievement. I've been a student at the Wagon myself 5 years ago. On the web development track, I know how intensive it is. So you can be proud of yourself. We are very proud of what you've achieved in the last few weeks. And we can't wait to see the projects that you built in the last few days only. For those of you who don't know the Wagon yet, very quick introduction. So we are a coding school. We've been trading since 2013. It's been a while now. We are present in 45 different countries. We've been training over 11,000 people. It's crazy, all in person. Recently hybrid with COVID, but very much back on campus with our students. And you'll see something today, at least you realize watching the demos that we have a very hands-on approach to learning. We very much believe in learning by doing, hence why everything that our students learned in the past 9 weeks now turned into projects that they will present today. We have 2 flagship courses that we offer across our 45 different cities. Of course, the Data Science Bootcamp that our 12 students will graduate from today, and the web development bootcamp. We just had another demo day, which has been recorded in case you missed it. Again, these are the two courses that we run on a quarterly basis in Amsterdam and elsewhere, of course. Now, you might be wondering why, professionals from all walks of life and from all different types of backgrounds decide to join a data science bootcamp. It's a really good question. And there are different answers to that question. Some of our students really want to start a career in tech, join a data team as a data analyst, data engineer, data scientist, you name it. Some others want to work in a tech-related role, meaning leveraging on previous work experience or just different things that they learned, as well as their newly acquired tech skills to work as product managers, tech consultants, etc. Or even why not launching a company? A lot of us dream of launching a company and having some impact and bringing some values to people through something that you build together with a team. It's what more than 250 companies did just after the Wagon. So, why not you? Why not our students today? The curriculum is jam-packed. It's a lot of learning. It's a lot of information. We've tried our best working with industry experts to over 9 weeks to cover all the core building blocks of what we call data science nowadays. Of course, these are foundations. These are topics that allow us to provide our students with the toolbox necessary to then start a career in data. And trust me, 450 hours of learning and hands-on coding in 9 weeks is a lot of work. So again, you should be proud of what you've done and what you will demo today. About the Wagon's mindset, again, data and tools are here to solve problems. Yes, it is here as well to help companies make informed decisions, but it is very much here to help us make this world a better place to solve problems. And again, you'll very much see that during the demonstration in a minute. All of this wouldn't be possible without our amazing teaching team that was led by Turk and Noor on this data science bootcamp, together with all the other lead teachers and teaching assistants. Thank you so much for all your work, all your commitment, all the effort that you put into this journey. You're really part of this roller coaster with our students. And they can really feel it. We can feel it. This is what gives us the energy to keep training more and more people, and that gives us all this motivation. So again, congratulations to all of you, and thanks for the past 9 weeks and a lot more. Now, today it's all about you. It's all about batch 627, 12 students graduating today. It's been a hell of a ride, and we just can't wait to discover what you've built. Now it's your time to shine. It's your time to to show us what you have been working on behind the scenes. Okay, we had a couple of teasers, I have to say, but now it's time to show the world what you've been doing. So I will invite Turk, our batch owner, on stage to say a few words and, of course, introduce the first team and the first project.
Thank you, Alex.
I see that Turk is connecting. Here he is.
Yes, thank you, Alex, for the wonderful intro.
Not sure I can. Yes. Yeah, perfect.
Yeah. Okay. Hello, audience. Hello, class. My name is Tjer Kostelijk. I'm standing here as a very proud teacher. I can talk a lot about how amazing the students did, but I want to just show you 2 anecdotes because I want everybody's attention for the demo days. One anecdote was a typical day in the Wagon Bootcamp, where I always start the day 9 sharp, trying to find students that are late so they can bring cake. And then everybody was on time. Okay, damn it. Again, no cake for me. Everybody was on time. I always take the promise, this lecture is going to be short. And eventually I go over time because this group was so interested in data science. It was easy to teach them in half an hour more of the work. And then in the afternoon, they will do challenges. They would practice the theory. I learned them in the morning. And we have a system where they can ask questions. And the first week, when they have an error, it's like, check, no, I have an error. It's already the second one. I don't know what to do. And at the end of the bootcamp, they supposed to not need me anymore. But it was already, I think, in week 2 or week 3, where I thought our system was broke because I didn't get any messages anymore. So I was working from home, and I was like, what's going on? I'm just going to go to campus to see what's going on. I came to campus. I see a room full of students, and they're fixing all the challenges together like an oiled machine. I know this, I know that. Hey, somebody knows how to drop a column? Yeah, I just did it. The syntax is I will send you a link. And they, as a group, were solving all the challenges, and that was so nice to see. The system was not broke. The group was actually super autonomous. So big compliments on that. Second anecdote, we were quite sad. Some people had some losses. Some people got sick. We had like a Blue Monday lesson, and then there was David from Sweden, and he just grabbed his dog and put it in front of the camera. And he's like, hey, I'm just going to show my dog. Maybe it will make the people feel a bit happier. I remember this moment. It was really nice. Okay, the third and last anecdote is the project weeks. It's 2 weeks of hard work. First week, at the end of the week, we do a midterm presentation. It's a little bit, what can you present in just 5 days? Huh? So it's always like, we cannot present yet, or it's not yet done. So we did the presentations, and I was like, is this already the final presentation? Because all the project presentations had such a beautiful level already. So that I really enjoyed it. And so compliments on working so effectively, but also working so hard. Some people took trains from Delft. Some people worked until midnight. Everybody did their own thing on working super hard. I think you can be very proud of yourself. And now let's go to our demo days. We have 4 presentations lined up. And I'd like to welcome the first team. The team is located in Sweden and connected remote through the whole bootcamp. I hope to see them one time in person. If I go to Sweden, I know where to find you. If you come to Amsterdam, please visit us. Let me introduce you team Auto X-ray Diagnosis, David, Kim, and Christian.
So, hey,
let's share the screen first.
Yeah, we're starting the share screen. See the entire screen. Cool. Okay. Yeah, great. Okay. So thank you, everybody, for your time and attention. And thank you to everybody at Wagon, the teachers, the TAs, and our fellow batchmates and team members. So like, that's just a good beginning. So this project that Kim and I will tell you about today is a project that Kim, Christian, and I worked on. And the title, as you can clearly see, is Automated Tuberculosis Diagnoses. So just in a second, the project has three parts. So the problem, so tuberculosis is a very tragically common disease. The solution, or the thing we like to add or do, is to come up with a way to flag tuberculosis in chest x-rays. And the way that we do this, we use image processing and forecasting techniques from artificial intelligence. So just a little bit of background. So tuberculosis is very widespread, and diagnosis is difficult and expensive. So to give a sense for how widespread it is, 23%, or roughly a quarter of the world, has latent tuberculosis in their bodies. This is the #1 killer outside of COVID worldwide. So for example, in 2018, tuberculosis killed 1.5 million people, as contrasted to 2020, where COVID killed about 3 million. So every 2 normal years is about 1 COVID year, tuberculosis wise. So tuberculosis shows up in lung x-rays, and you can, if you're trained, you can see it, but it's sort of costly because most of the people who have tuberculosis are in relatively not very well off financially countries. And so they're resource limited and monetarily limited. So it's nice if you can come up with a way to write a program that will describe whether or not you have or may have tuberculosis. So the structure of this presentation, the structure of our design of the program, is roughly broken down into the following 3 steps plus a demonstration. So first, we write a program that learns the shape of a lung. The reason why we do this is, as you can see in this lung x-ray, there's lots of extraneous nonsense that has nothing to do with tuberculosis. There's the shoulder bones, there's the clavicle, there's the heart, there's a hip, there's a vertebrae. It's really important to just tell the computer to focus on the relevant part of the image. When it can do that, it can then do the second program, which is learn what tuberculosis looks like by comparing healthy and tuberculosis positive lungs. So after we've developed this program, then we made an app, which we'll show in a minute, where you input the x-ray and it runs the program behind the scenes, and then gives you a prediction of whether or not you may have tuberculosis. And then we'll give a demonstration. So it's just important to say at the outset that this data set, that these programs were trained and built off of a publicly available set of 800 x-rays that were taken in the United States of America, actually in Montgomery County, where I was born, and in the People's Republic of China. And this is the website for the relevant x-rays. Okay, fine. So the first part of the program is telling the computer how to recognize the shape of a lung. So as I said before, lung x-rays have the pretty images have lots of extra features that you do not want to worry about. And so you want to train the computer, or tell the computer how to figure out what is the shape of a lung. So we do this by using a self-training program that learns the shape of a lung. So basically, we give it chest x-rays and human-drawn outlines of the lung, and give it tons of examples and let it just essentially teach itself via functional units that are very closely analogous to neurons in brains. And so in the same way that a toddler learns how to draw things after doing a lot of examples, the program does as well. And so when you run it longer, you get better results. And this video showcases a particular case of given an x-ray and then this outline of the lungs right here. It then it will slowly reproduce this. So these images illustrate the shape that it will infer from the x-ray of the actual lung. And as you can see, when it evolves, it finally gets to a very fixed state, which is very close to the actual outline. And so with this, now I think it's Kim's turn.
All right. Thank you, David.
That's a little slow.
All right. So the next step in the program is, in essence, to teach the program to identify tuberculosis. And now, personally, I have no idea how TB looks like. But I could probably, given enough time, I could probably learn it, although I would probably need 5 years of medical training. But our program just needs 1 hour to learn with an accuracy of 81% how tuberculosis might appear in the lung without any medical training whatsoever. And that's, I think, is very, very impressive. So this is done by just feeding a bunch of images, healthy versus non-healthy images, and given enough time and training, it could learn from its mistakes, just like we do humans. Just learns from its mistakes, and given enough time and images, the more images you have, the less mistakes it will make, the better accuracy it will get. To tie things together, we basically have a line-shaped model, this image like here, and we take this image and we feed it into this TB signature model, which basically predicts if you have tuberculosis or not. And we do this because, as David mentioned before, it's actually makes the program better. It makes it smarter. It knows where to look at. It knows like tuberculosis is somewhere apparent in those areas of the lungs, and that makes the accuracy better. And in the end, it will return a probability of having tuberculosis or not. Now. And this is, of course, general way of pointing at an unhealthy lung, just like our program learns learns and how an unhealthy lung looks like just by seeing it, just like we do. All right, let's do a live demonstration. But before we move on to that, it's important to do this disclaimer because we are really not doctors. We have no idea what tuberculosis looks like, and this is. So if you want medical advice, just go to a doctor. Don't go to a program. But this is just for purely demonstrative purposes. All right, let's open this website. This website you cannot be accessed by everyone, and let's open it up. And it looks like it's very minimalistic. It just has one button. It has a disclaimer right here, and it expects you to upload a PNG of an X-ray image. And we can do just that. We have prepared 2 X-ray images. One is a healthy lung, which a doctor told us it's a healthy lung, and one is an unhealthy lung. Now, I personally don't see any difference, but hopefully our program will be able to tell the difference. And it's important to point out that our program has never seen those images before, so based on how it learned, it will probably be able to tell if this image right here is healthy or not. Let's see what happens. We open this, and here's the X-ray image that we just uploaded, and now we just have to wait a few seconds. Just bear with me, it's diagnosing. We could probably upload images of your cat as well, but we don't promise for any good results for that. Let's see what happens. And there we have diagnosis negative, means there's no TB present in this lung, just like the doctor said. And we also have the resulting segmented lungs. And lastly, let's go and see what it does if it's an unhealthy lung, if it has actually tuberculosis. Let's open up this file. And we'll be diagnosing now. Just give it a few seconds. And this went faster. And indeed, diagnosis positive. This lung actually has a high chance of actually exhibiting tuberculosis. And just for fun's sake, our website would gently point you, if you're in Sweden like me, or in any country with socialized healthcare, you can actually click on this link, the Skyscanner, for cheap flights to Poland, because you can just keep the line there. All right, I think that's about this, and thank you for listening.
Yeah.
It was very, very fun to do this project, and stay healthy, and keep your lungs healthy as well. Don't smoke.
Thank you for your attention. It's been a pleasure and an honor working on this and working with all of you.
If you have any questions. Okay, so if you have any questions, you're welcome to ask them.
And if you are a guest in this session, you can also ask a question. You can do it by asking the question through the chat. So if you have a question, go ahead.
Don't be shy.
How about you guys? I have a question.
Yeah.
Yeah.
Are you gonna bring this beautiful work to a hospital, or how are you going?
We already have a logo.
So-
as you saw, we have a logo on our website, so we all have plans to monetize this.
I think the WHO has a threshold detection of something like 93. It has to be 93% accurate. And so we are 81%. So I think it's a little bit below medically acceptable thresholds. But they're actually, so when we emphasize that our model is not state of the art, however, it's not far off. So if you look at the literature from 4 years ago, published papers, they have 83% success on the same data set. It's not so far off. And if you look, people have done more recent analysis using pre-trained models. We intentionally use models that we just built ourselves, no weights, nothing inferred from the outside, and we got to 81%. But using these pre-trained models, they're able to get like 99.7% accuracy in diagnoses. So I think we're a bit behind.
Yeah.
But
We also have a question for Noor, from Noor. Can this be used to detect other diseases? Indeed, it can if you feed it. The architecture will probably be the same. We don't have to change much. If you have enough images of, say, COVID lungs or pneumonia, you could probably seamlessly just teach it to detect it. And it also, of course, depends on how good those images are. But yes, you can, or in a simple and short answer, yes.
And indeed, we might do this as a follow-up project
Yeah.
to just better understand once the model's improved a bit, just because it's a relatively straightforward exercise. Relatively.
Okay, well, good luck with this. I have to welcome the next team on stage because of the time. But let's do one more applause for Team Auto X-ray Diagnosis. You guys nailed it.
Thank you.
I welcome on stage the next team, AI DJ, Judith, Willem, and Amin.
Let me have a look. Sure. No, see it now. Cool.
So
Sorry, we're sharing the screen. Sorry. Hi, good afternoon, everyone. So, yes, are we ready to go?
Yeah.
3, 2, 1. Well, ladies and gentlemen, good afternoon. Today we're going to talk about music composition or DJing for dummies. So yes, I think what we've all been waiting for during the COVID is to have a great party. And of course, what's better to have a party at your own house and have your own DJ, or like be your own DJ yourself and create your own music style. And so Amin, Judith, myself, and of course our team leader Bear, or Beer in Dutch, have decided to create a tool which will allow you yourself, that you can by yourself create music. Because what we notice as a pain is that if you want to produce music, it's very complex and very difficult to start it by yourself, because a lot of know-how, time, and creativity you need to actually produce a song by yourself. And that requires, well, as it requires a lot of time and knowledge, it's reserved for the experts, the DJs, and it becomes quite difficult for you and I to make a good song. And that's why we decided to do this. So how does our tool work? You insert a YouTube link, as you can see over here. So if you say, okay, I love Justin Bieber, you copy paste a link on YouTube, you insert it in the toolbar, and then you press create. And what then does happen, the system will look for very similar songs. So this is like, okay, well, this guy or this girl really likes Justin Bieber. We'll look at something similar, and then it will create a unique song based on very similar songs that you inserted. And of course, we all have different styles, and we all have different preferences of songs. So we want to make the system better and better. So how do we do that? You have a rating system where you can insert, say, okay, well, I love this song, I give it a 10, or you say, well, could be better, I'll give it a 2. And then the system becomes smarter and smarter and will create a unique song to your liking, which will have your party will be amazing, and you will be the DJ of your own party. And of course, a lot of magic behind all this. So Amin, my colleague Amin, is gonna further explain to you how the magic happens.
Thank you very much, Willem. I continue by, first of all, providing a broad overview of how our system actually works. As Willem mentioned, first, the user inputs a song, and then we have some functionality there to be able to help the AI actually put the different tracks together. Then it will actually generate a mix, and finally we retrieve the information from the user regarding the rating in order to enrich and improve and teach it better how to produce better music. I will briefly discuss the first step in which, as I mentioned, we need to help the AI a little bit in order for it to be able to make rhythmically pleasing remixes, let's say. So did you know that an AI is actually capable of taking an original song and breaking it up into the various instruments? I let you hear a sample of a song here. And I have to pause it. It's a lovely song, but we have to continue. And here you can hear, for example, what it thinks that the drums should be. Again, I give you another example of what it thinks the accompaniment to the drums should be. So as you can see, and I will shut this down, it's actually quite good at sort of breaking it up into the constituent elements. And we need this in order to be able to make a new mix of different elements. The next step that we had to think about was that we have to also teach the AI to get a feel for the beat. Now, as human beings, we do this quite naturally. You hear a song, you can instantly, if you have some minimum amount of rhythm, you can tap the beat. But you can also teach a computer to do this. So we have an original song, which I won't play it again because it's the same song, but we create markers for where the AI thinks that the downbeat should occur. And I will play the result, and you should hear the identified downbeats as a sort of blips or clicks. And I hope this is audible. Quite good. It really is able to identify the downbeats quite well. I will now give the word to Judith, who will talk a little bit more about the AI itself. Thank you very much.
So thank you so much, Amin and Willem. I think it was very well explained. So let's go to the next step. So now that we have the user song and we combined it with another song, or we chose a song that is quite similar, we have split the song into the different elements, and now we need to create a mix. But how are we actually doing that? Well, you can think of it like this. Say you have two songs, one song of Chesto and one song of David Guetta, which are two quite famous DJs, and we split them into the individual tracks. So we have the drums, the bass, the vocals, and the other of each of the tracks. What the AI will do is it will randomly pick 4 of those stems, 4 of those items. So it will pick the drums and the other from Chesto and the bass and the vocals from David Guetta, and it will then make it into a new mix. So it has all of these elements of the 2 songs. And I'm now going to play you a song that is actually created by the AI. So I'm wondering what you think of it. Sounds pretty good, right? So this was made by our AI. We're very proud of this. And it sounds pretty good because it has a drum, it has a bass, it has some vocals. You can't hear it now because it is later, and it has the other. So that's why it sounds very balanced. However, we can also have the AI, because it's random, it can also pick 2 basses, a vocal and other, and have no drums. So then we will have a mix of this without any drums of it. And this is what it sounds when it doesn't have all of the elements. So the ratings are mixed on this song. Some people love it, some people don't love it. But that's also the idea, right? Some people have a different version of what they like for a track than other people. So then how do we know if it's a mix that is very pleasant to listen to? Well, we predict the rating. And in order to explain this, I'm going to give you a metaphor of that if you're cooking, you're using ingredients to create a mix. And for example, in the audience, who here likes salmon? Check. You like salmon. Have you ever tried salmon to combine it with chocolate?
No.
No. Why not?
No. Never tried it before. But I have a feeling that it doesn't combine well.
Yes.
That's why I didn't try it before.
So you have a feeling it doesn't combine well. Well, that's probably because in your past, you have experienced that this combination doesn't really go well together. That's why you also, if you have tried it and you don't like it, you'll also know that this combination, shrimp and white chocolate, will also not work very well together. So we as humans are trained to know which combinations mix well together. But the AI doesn't know that because it hasn't seen those before. So what did we do? Well, we trained it. We created 300 mixes. Well, the AI created 300 mixes, and then we rated them with our team. And so this is a summary of the rating. So most of the songs got like a rating of 5 or a 6, and the range is 1 to 10. So that's actually pretty good. But of course, you can see there's also some songs that didn't rate very well. So how do we use this? Well, now that the AI knows what mixes go well together, the next time it plays a new mix, it will listen to what elements are in the track. So does it have any drums? How fast is it going? Does it have any vocals? And then based on what it's learned, it will give it a rating. For example, a 7. So how does it fit in the whole schema of things? Well, after we've created the mix and predicted the rating, if the rating is not higher than 5, it will probably not be very nice for the user to listen to. So we just simply try again, up until we have a mix that is bigger than 5, of a rating of bigger than 5, and then we output the mix. So this is how we are making AI DJing for everybody, and this is how everybody can actually make music without having the expertise of it. So I'd like to thank, of course, my team, because it was a lot of work, but it was also a lot of fun. And of course, the teachers and the TAs that are been very helpful and have taught us everything they know. And of course, you as the audience for listening to us. So thank you very much, and please let me know if there are any questions. Let me stop the screen sharing. So, oh.
It's okay. I will fix it.
Oh, okay.
It's okay. No questions?
So any questions? Don't be shy.
Anna loves it. That's all.
That's
Thank you.
I have a question. What are your future plans with this?
Well-
Sounds very promising. I want to hear more music of it, maybe even pay for it.
Well, so the more people use it, actually the better it gets because it's learning from the songs. And then we could also use it, for example, if there's a specific company that wants music but doesn't have the creativity to create it themselves, we could maybe let them use the AI even if you want to pay for it.
Yeah.
So yeah.
More questions?
We're selling some equity in half an hour.
So I see that there's also a question from Kim. So can this be done for other kinds of music as well? So we base it now on electronic music, but well, give it a shot. See what happens if you put in a jazz song, for example, because the beat tracking will actually very much mix it as well. And then Anna says, can you also just take the voice out? Well, you can because it's only it is extracting the stems. However, the mixing part is just a random process, so it will randomly either take a voice or a drum. But you could, for example, alter it a little bit so that you have only the voices. And have we ever tried mixing Ed Sheeran with Justin Bieber? No, but I think it will work very well because they tried it before. They did it themselves, so give it a shot, and we'll see. Thank you.
Nice. All right. You nailed it also. Really nice. Well done. I welcome the next team on stage. It's going to be Andreas, Marusha, and Hidde with AI Pictionary. And Marusha is from Brussels online with us. So I will invite Marusha on stage.
Yeah, good afternoon, everyone.
Hey, yeah, it's working.
Great. I'll be the one sharing my screen, and then Hide will take over afterwards. Okay, so let's do this. So can everyone see my screen first? Okay, I'll take that as a yes. So good afternoon to everyone. Thank you for joining us and looking at our presentation. So we are team 4, and so Andreas, Hide, and myself are going to present you our project, which is an AI Pictionary. So what's this about? The idea was to teach an artificial intelligence to recognize a user-generated sketch and play Pictionary. So user-generated sketch is a sketch that you will be drawing, and the computer is supposed to find out what it is. So most of us are familiar with Pictionary, a board game that you play with family or friends, and where each team has to recognize the drawing of the other players. But sometimes you're on your own and you don't have friends to play with. So today you're not going to play with people, but with a computer. And coming from this, the challenge, of course, there are, as in every project, there are some challenges. So the question here is, how would you draw a car? Obviously, this could be a car, this one too, and these two are recognizable, but sometimes you might be drawing something a bit more weird or unrecognizable, and that's the challenge here. So as you see, we only have 8 drawings, but there are infinite possibilities as to draw a car. So how to solve this challenge? We used the Google Quick Draw dataset that consists of 345 different labels. So what is a label? It's a category. It could be a cake, a car, a crown, a fork, and many others. And under these 345 different labels, there are 50 million individual drawings recorded. And this huge database helped us to solve the issue of recognizing and to lead us to elaborate a nice model. And to explain this, I will pass the torch to Andreas.
Yes. Thank you very much for the introduction. So yeah, I will go straight to the nerd part, to the approach. So how do you teach an AI actually to recognize a picture? And what we used is deep learning with a convolutional neural network, CNN. So those fancy words explained simple. So for example, the CNN is mimicking the brain. And so when you go through the park and you see a dog, what happens in your brain that all the neurons are connected to each other and are communicating, and in the end you recognize it's a dog. And in the end, because we know already from the past presentation, it's not just a dog, it's a bear, the dog from Willem, which is very nice. And this is in the end how the CNN works. And if you go to the next slide, Marusha, please. Yes, so we in the end trained, as we call it in data science, to teach an AI, we train 3 models. We didn't use all the 350 labels from the beginning because it's such a massive data set that it might crash after a few days and you have no results. So we started with 50 labels and there were roughly 2.5 million drawings in it. And that you can compare to like a toddler who just calls everything a car that is like going around in on the street. And then it worked quite well actually on that, and then we scaled it up to a medium-sized model, CNN with 150 labels, which is already a small kit, and it knows already the difference between a car and maybe a truck and a tractor or something like that. And this was our, I would say, it's the medium-sized model. We worked very well. And in the end, we managed to run one model with 250 labels, which were roughly 22.5 million drawings that we trained. It took 24 hours on the Google Cloud. We sent it there to train it. And there, this is already very specific. So it knows already many different words, and you need also a lot of different images, so you get a difference out of that. And now I also want to cut it short because, of course, the most interesting part is the results. So what does our AI really predict?
And for that, I would like to invite Hidde to the stage, take over. And
thank you, Andres. I will open. Is the one now closed? Yes. Let me see. I will open the presentation again. Oh, yeah. That's why I used 2 tabs. Sure. So, and in this case, I will showcast our demo a little bit with a video, because when I try it myself, especially now when I'm maybe a little bit nervous, the pictures aren't coming out that great, and I have a tendency to curse a lot when it doesn't work out. So, yeah. So what you see here is in the middle. Can you see it? My mouse moving? No, right? In the middle. Yeah. In the middle is our canvas. There we can draw. On the right hand is our AI prediction. And on the left is what Andreas just told us about, like the little kid growing up, learning more images. I will start now the movie or the video. And we start at 50 different labels. And this is going to be a suitcase, obviously. And I'm a very good drawer when there's no pressure. So you can see the accuracy of this one is 99%. So that's quite good. When we go to 150 different pictures, it goes to 85%. And what you can see is, so they added 100 more pictures, and you can see a television is now 7%. So the computer recognized the shape also being used for a television. And then we go adding another 250 labels, pictures, and now is there also a toaster. So the toaster wasn't in the 150 labels, but it kind of looks like a toaster with a little bit of toast going out of the toaster. All right, now we're going to show a little bit more of a game-like drawing, where people, when you are with friends and someone, and when you think, oh, let's play Pictionary, someone starts drawing, and you can already see the computer is like, okay, it can be this, it can be this, it can be this. And in this case, it's a sort of car. And the computer, or the AI in this case, says maybe it's a pickup truck, or a truck, or even a train, or a car, or an ambulance. And it's pretty divided, so it doesn't really know what. So in this case, you have to be more specific on what it should be. So I draw a siren. So in this case, it's obviously an ambulance or a police car. And there still is a train, because it still looks a little bit like a train. And there's also now a fire truck and a car. But I wasn't still done with the drawing, because it's supposed to be a fire truck, of course. So this is kind of how you would play with friends. You add something and you try to improve your picture every time, and in that way you get to the right solution. And in this case, it's 55% of recognition of a fire truck. And what we added on this page is also, if you're not really creative, we added all the 250 labels under this button. And there it shows 5 random labels that are in there. And then you can choose, if you don't have a clue how to draw it, to put it in the button below. And it will provide a picture of how it was trained. So it will showcase pictures drawn by other people that are in the database. So that was that part. And one more minute. Okay. Doesn't it go now? Yes. In this case, we want to thank the team, the teachers, Turk,
Noor, of course, and Ayn. And also, we didn't put all the TAs, I'm sorry, but the 4 that were, I think, the most of the time here with us, Bruno, Alexis, Richard, and Mathieu. And also I want to like to thank Andreas and Marusha. We had a lot of fun making it and playing around with it afterwards. And I want to end the presentation with the words we all know of the kid lecture. Now it's your turn. So you can go to ai-pictionary.herokuapp.com to try it out. And if you have any questions, put them in the chat. Thank you. Any questions coming?
We have to moderate for your questions.
Okay. All right, we can leave it on for.
No questions yet?
Good. All right, thank you. Bye.
Okay, that's how we do. No questions is no questions. All right, very impressive. Okay, and then we arrive already at the last presentation of today. I hope the audience remote still has some energy. It's always a bit harder to watch it from a screen than in real life. So get your last energy together for the last presentation of today. I'd like to welcome Mikael, Christina, and Felix with the Wildfire Project. And that's gonna be hot.
Am I allowed to? It's working.
Second tab, tweede tab. Tabblad. Je hebt 2 tabbladen bovenin.
Oh,
Ga
here.
naar de tweede. Ja. En dan ga je.
Yes,
Ja, sorry.
got it. So welcome everyone. This is the last presentation of the Data Science Bootcamp. I hope you all have some extra energy in your left because we're going to add some last heat to it with our presentation with our presentation about wildfire predictions in Australia. This project is done by Felix, Miguel, and myself. In the past 2 weeks, we worked very hard in making this prediction system. I will give you a slight introduction about what our motivation was about doing this project. Then Felix will explain how we approached the problem at hand. And then Miguel will show a demo of our final products. So everyone knows the sad news stories about wildfires gushing through dried out hotlands that were very difficult to turn off. In the past 20 years, according to the World Health Organization, 6.2 million people were affected by losing their homes or getting burned by the wildfires. And our most recent one that was everywhere in the news, like in 2020, before a certain pandemic happened, was of course the wildfires gushing through Australia in the beginning of January. Everyone saw heartbreaking images of koalas that lost their homes, just like the one you see in the image. But that is not that's not an uncommon case in Australia. 1,800 wildfires are going through Australia per year. So we were also heartbroken by these images, and we wanted to figure out, can we do something about this? Can we predict the wildfires before happening so that there can be more preparations done at hand? And can we also determine the size of these wildfires? So that's how that was our goal, and now Felix will explain what we did.
Right, thank you very much, Christina. So how do we plan to approach this actually huge problem? Our idea was to build an interactive map of Australia, and it's supposed to look somewhat like on this slide, where you see Australia, and then you see bubbles, the places where we would predict a wildfire. And the size of these bubbles, you might notice, is different, and that's because the size of those bubbles refers to the size of the fire that we would predict. And if you would actually click on the bubbles, you would also see the probability of the wildfire actually happening. But more on that later by Miguel when he shows us the demo. Let's first think about the data set that we used to build this product. We got this data set from the multinational company IBM, who hosts a challenge on predicting the size of wildfires. And we decided to extend that challenge even further by predicting whether there will be a fire at all, because what's the point of predicting the fire size if there's no fire at all, right? So this data set is 41,000 data points strong, and it's divided into 3 categories, which you can see on the slide. The first one being weather. This includes things like temperature, humidity, precipitation, which is like rain, hail, snow. Snow, maybe not so much in Australia, but still the point stands. And that makes sense, right? Because if it's a hot day, then there's a high likelihood of fire happening. The second category is the terrain. That just means what's the dominant terrain in the area of the fire. So, for example, if it's a city center, it's less likely that there will be a fire compared to a forest, for example. And the last category is the vegetation, which just basically means how green and how dry is the area. So a very moist green forest is less likely to burn than a very dry forest, for example. So, ironically enough, given that we predict wildfires, the model that we use to do this is called a random forest. And if you hear that for the first time, you might think of something like that. Unfortunately, this is actually not what we're going to use. To understand what we're going to use, or what we use, we have to first understand the decision tree. On this slide, you can see an example decision tree. And the logic is just that at every stage, there's a question to be answered, and that will result in some outcome. So let's just walk along the line of the orange bubbles. The first question to be asked to you or the computer would be, is it a hot day? Apparently, it is a hot day, so you walk to the yes side. And then the next question will be, is this area a forest? Apparently, it's not. And the result is that there will be no fire. Obviously, this is super simplified, but if you think about it, this is how you make decisions every day in life. If you think about, okay, do I want to go outside? Yes. Is it raining? No, so I don't need an umbrella. So these kind of decisions we do every day. And what we train the machine to do is ask the right questions and also in the right sequence. And by training the model to do that, it can predict whether there will be a fire or not. So if we now understand what a decision tree is, the next step to the random forest is not as far anymore, because the random forest is just several of these decision trees. So on this slide, we have 3. Each of them have a result 1, 2, and 3. And what the random forest would do, it would just take the results and either vote or average them in order to get the overall prediction of our model. The best part about this is it actually works. We predict 17 out of 20 wildfires in Australia, which is pretty incredible. We feel we're pretty proud of that, and we think that we can actually, or we do actually have a positive contribution to, Australia in this case. So let's just recap it a bit. We have a data set with 41,000 data points, which is divided into weather, terrain, and vegetation. We give that data set to our random forest, which will predict whether there will be a fire at all, and will predict the fire size. And this will result in an interactive map, which Miguel will show you now how that looks like.
Thank you, Felix and Christina. Great introduction. Hello, everyone, and thank you for making it this far. I will now guide you through our end product and show you how you can interact with it, how you can use it. I will do that with a quick demonstration. Let's dive into it. So you can see that it's fairly simple. It's a map of Australia on the right side of the screen, and you have 2 user inputs where you can select the city, and another input where you can look at it and you can select the number of days, 1 till 16, because it's a reliable forecast for weather. You might see that by default we have 7 circles on the map. These represent the 7 states of Australia. And you can already see that there are different sizes, like Felix mentioned, for each bubble. We call it bubbles, these red circles that you see, and you see that the difference in between the radius is proportional to the estimated fire size. That means that a bigger fire size have a bigger circle, a smaller fire size have a smaller circle. Once you click a circle, you will have the state name or the city name. You will have the fire probability, in this case 57%, and the estimated fire size of 180%, 180 square kilometers. Sorry. You might notice that a smaller circle, like I mentioned, will have a lower estimated fire size. And this is it for our default mode. And then you can, as a user, select whichever city you want. For sake of the demonstration, we will use Perth, a city in the southwest of Australia. In the backend, our model will then retrieve weather conditions for tomorrow, because in this case it's looking 1 day ahead. It will combine it with all the data that Felix mentioned before, vegetation, terrain, if it's a forest. It will feed it to our models, and it will generate some values. This is just a fancy way to showing it through this interactive map, our results. So you can see that the fire probability is 89% for Perth and estimated fire size of 180 square kilometers. We can then look at 5 days. Our model will do exactly the same. We'll go through the API. An API is just a way for us to communicate with a weather service provider, get the forecast in 5 days, and then it combines exactly the same way the data together with the data that Felix mentioned, and it will retrieve then the new possibility and the new fire size. It's a fairly simple and platform. You just have 2 inputs. I hope you can play with it. You can see around. And moving forward. On the right side, you see an image that it's actually from a government institution in Australia, where they track all kinds of incidents. If there was an earthquake, if there was a wildfire, if there was some warnings, and it actually, in this case, shows a fire in Perth that actually was predicted by our model. So we know that it works. And as future work, we would like really to scale this project worldwide. Is one of our suggestions would also to be implement a warning system or some kind of notification for a user that uses this application, so that he knows there is a high probability of a fire and there is an high estimated fire size on that region, and get both governmental organizations or non-governmental organizations to use it. We understand that the area of Australia it's like massive, and the firefighters especially cannot allocate resources everywhere. So in this case, it would be nice to have a system that can pinpoint where will be the most danger area and where can you have some more trouble, more estimated fire sizes, and that would be really useful. This is it for our project. I will now like to thank my team members, Christina and Felix. Thank everyone from the Wagon family, especially our colleagues, our teachers, TAs. It was amazing. We had a lot of fun. And with this project, we feel like we are adding something valuable out there. It feels our heart to do so. So thanks everyone. If you have any questions, feel free to type in the chat. Or if you are in the audience, just shout out and we will do our best to answer. Thank you very much.
There's one question from the virtual audience. So the question is, would it also work for other continents? You have maybe mentioned it, but
it would definitely work for other continents. So we did our project in a way that all the data that we collected can be collected for different continents, different regions. The only fact is that it was provided by us by IBM, like Felix mentioned. It was easier to gather, but it really can be scaled worldwide.
Nice. The second question is related. When will the wildfire prediction be there in Portugal?
For Portugal, well, amazing. I think we are a bit behind when it comes to data services and to gather all the data, but we will work on it for sure.
And then another question: how does your algorithm perform compared to others?
To others.
Other algorithms.
Other algorithms.
Oh, yeah.
So in this case, we chose this algorithm because it gives us the best results. Like Felix mentioned, I don't want to get too technical, but we chose this random forest because it learns how to ask the best questions because we have many features. So you can see features as variables like wind speed, like temperature, like solar radiation, and it learns how to make the right questions in the right order so that it retrieves then the best probabilities and the best fire estimated sizes. There are any other questions?
Yep.
Awesome. Should I give the stage back to?
I think the last question was more meant like, is there any other work on prediction on fires that you compared your work with? Yeah. Maybe Felix knows? You can an answer is also
there were several models that we have seen online, but none of them actually predicts if there will be a fire or not. But there are actually models that predict fire size, and indeed, not getting too technical again, our root mean squared error would be less than 50, and the best product that we've seen before that would be around 28 to 30 root mean squared error.
Yeah, maybe to mention, to add to that, the other team that participated in the challenge to do the fire size that got the root mean squared error of 20, they had like, I think, a few months time to do that, and well, we did it in 2 weeks. So I'm pretty confident actually that if we would have more time and we can work on it after the bootcamp as well, we will be able to match that.
Totally.
Plus, you predicted the fire that was actually happening. So
yeah.
Okay.
Thanks, everyone.
Thank you. All right. Then one last word from me, and then I give the word to Alex. So, dear students in Sweden, David, Kim, Christian, and also dear Marusha, you are all graduated. Having the title Data Scientist, Wagon Data Scientist. So congrats, you will get the certificates. We are going to post them, mail them to your homes, and this afternoon we're going to celebrate this success. I'm going to give the word to Alex.
Thank you, Chirk, and yeah, thanks, Chirks, for leading the students through this adventure together with the rest of the teaching team. I've been at Wagon for a couple of years now. It's always a massive reward and satisfaction to see these projects, to see so many talented students graduating from all different backgrounds. So I really hope that you enjoy the ride, that you are proud of what you have achieved with our teams. Again, you're joining a massive family, a worldwide family. So of course, make the most of this amazing network. It's over 11,000 people worldwide. It's a lot of us, and very happy to welcome you today to this amazing family. Again, thanks to our teams in Amsterdam, thanks to the team in Stockholm as well, Eva and Vendela, who have been taking very good care of our students over there. And now I think it's time for some celebrations. Take good care of you. Enjoy the weekend when it comes, and we'll see you next week for Careers Week. And to all of you who attended the event remotely, thanks for attending, and see you next time. Bye, everyone. Take care.